All right, hey guys, Mr. Fortin right here. Going to take you through some notes. Now, these notes are really only if you did today's lesson, which was about the rule of four, and you haven't really heard about this too much. And it's totally fine if you haven't. Once we get into Algebra 1 in the textbook, it's going to reteach you this, bring up the rule of four again, keep practicing. So it's really only if you really had trouble kind of with the Desmos today. And again, your homework, part of your homework was to finish the Desmos assignment we did in classwork today. If you're really struggling with it, then definitely watch this video, because what I'm going to do is I'm going to take you through 3 examples, one in detail, one that I'll do kind of quickly, and then one you'll do kind of on your own. But I'm going to kind of explain how, when you have a pattern, a tile pattern like this, like here we have pattern Z right here, how you can complete the 4 algebraic representations. And this is also known as the algebra web. A lot of words here. A lot of words get thrown around. Some are more important than others. I would say rule of 4, kind of important. Algebra web, kind of important. But you mostly just keep an eye out for it kind of in the future. Okay, so we're going to complete the 4 representations of this tile pattern. We'll do each one together. And then after that, I'll also do the thing where in your assignment that you did today, you were supposed to label where you saw the starting number in each of the 4 representations, okay? And with the starting number is where you see pile 0. So we'll get to pile 0 later. And pile 0 can be seen in all 4 representations. It can be seen in the table, graph, and equation, in addition to the situation here. And finally, I'll also take you through how you label the growth number, okay? So without further ado, let's get into it. So I'll make this nice and quick, and you can hopefully see it. And then again, email me if you have any questions. All right, anyways, we see in front of us here, rule of 4. That was today's class. I introduced the concept. You got to play with it. Maybe you're doing your homework now, but the 4 representations of an algebraic kind of expression or an algebraic situation or algebraic scenario is a written situation, a graph, an equation, and a table. Now, for pile patterns, because pile patterns aren't like really real life situations, like usually a word problem is real life situations, a pile pattern is just sort of symbolically showing you what's happening in a particular situation. So what I'm going to do is I'm going to label this situation. This is our situation for our rule of 4, is just the tile pattern itself. It's kind of showing you what's going on with this pattern. And now we need to summarize the pattern with a graph, a table, and an equation. Okay, so here's our situation. We've already done tile patterns like these. So this was the one where we were adding 2 over here, right? Remember, it was adding 2 here and adding 2 here. That was in my last video. So these 2 go away. So figure 0 looks like this one and this one. And we're growing by +2 every single time. Figure 100, let's not worry about figure 100 for this particular situation, okay? So now we need to change this into a graph, an equation, and a table. And what these double arrows mean is that you can go in between any of these, right? That's why I asked that question today in class, like, which would you start with first? And a lot of people said equation, but a few people said graph, not so many people said graph, but a lot of people also said table, So for me, when I'm doing completing my algebra web, completing my rule of 4, and I have a situation, what I usually do first, and what I'd recommend to you, because I think it's easiest, is to start with the table. And somebody was very smartly walking me through that about why the table is a good one to do first. And it's because all the information in the table is listed here, right? We just got to count what's going on here, okay? So that'll be the first thing I do to complete my web here is I'm going to go and I'm going to do a table. This, in the assignment today, they refer to this as an in-out table, an input-output table, okay? So our in is our figure number. That's our X, okay? Input. I might just call it input and output. And we have our output here, and this is how we can create an in-out table. Input is X, and output is the Y variable. Again, we'll review what variables are once we get into class here, okay? So our X variable here, input is figure 0, so we have 0. And again, you just have to count here. We have 4 tiles there at figure 0. Figure 1, we have the 4, and then we have 5, 6. We have 2 more, right? 1, 6. 2, we have, what do we have here? 2, 5, 7, 8. And 3, we should have 10, right? If this pattern is actually being consistent. And I think it is here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we have 10 for figure 3, okay? Could I make that longer? Yes, I could, because I know the growth pattern, but this is okay now for a table. Okay, so we have our situation taken care of. We have our table taken care of. Now I'm going to show you the graph, because we could go to an equation right now, right? The table's good because that's going to help us get an equation. I'll explain that a little bit later. But a table is also good because it gets us our graph, okay? So again, I wish I reviewed this in class, but a graph is, we could write it a couple ways here. I might do the graph like this. I might do a graph like this. See, this is really reviewing stuff from last year that you may have forgotten entirely. But I'm going to do a graph like this, where we have an x-axis and we have a y-axis. So here we have our x. Our x is our input variable. So that's our figure number. And our y is our output, right? Our output here is number of tiles for a given figure number. So number of tiles. Okay, so I did it like this, where I crossed these two lines here. And you could have actually done this and just showed this part here, because you should know this by now that this point of the graph is 0 for the x values, and it's also 0 for the y values. This is called the origin, right? The origin right here, okay? So if I go to the right here on the x-axis, that means our x numbers are positive this way. And to the left here, our x values are negative this way. It works just like a number line, right? Number line that we have here. This one here, our y values get positive as we go up and negative as we go down. So a little review and kind of read a graph here, okay? So really, I only needed to show this part of the graph. This is called a quadrant of the graph. Quadrant 1, 2, 3, 4. Anyways, you don't need to worry about that now. So you could have just drawn an L graph, right? That'll be something I'll say in class too, and other teachers may have said before. An L graph looks like an L, right? This here is where, the important part when you have an L graph, right? Right here, we're gonna look just on the L. Find the L and we're gonna graph it. The reason why we're gonna do this is because all these numbers are positive, okay? So if we have here, we gotta go up to 10 at least to sort of represent this. So I'm gonna scale by 2s. 2, 4, 6, 8, and 10. And I'll have a very small graph right here. So this is 10 here, 2, 4, 6, and 8. And for these are my y values for tiles. Notice here my y's only go up to 10 at least for what I want to graph. Like these are all going to be points on the graph. And then my x values are going to be 0, 1, 2, and 2 and 3. And that's what I want to show on my graph here, okay? So what I'm going to do is, well, we have a point actually at 0, 4. Okay, 0, 4. So I'm going to draw a point right there at 0. X is 0 and y is 4. We have a point right here, okay? At 1, 6, we have another point. So when x is 1, y is 6. So when figure number is 1, right? Figure number is 1. Number of tiles, right here, the y value, number of tiles is 6. So I'm going to put a point there at 6, okay? We have here 0, 4. We have here 1, 6. Next one is 2, 8. So notice here, the reason why I say start with table is because that makes it easier to come up with your graph, right? 2, 8. We're going to get another point right here, okay? And then we have a number 3, 10. Okay, 3 10s comes right here. And look at this, we have points here. And what do these points actually make? Okay, you could stop your graph like this. That's cool and all, but these points here, if I were to connect all, what would it look like? Connect all these points here. What does this look like? What does that look like, guys? It's a straight line, okay? It's a straight line. So this here has a straight line. If we were to continue, right, we would have at figure number 4, how many tiles should we have at figure number 4? Well, figure number 3 had 10. We would just add 2 more on top here, right? 2 more on top here. So 10 plus 2 is 12, so we'd have another point at 12. If it were 4, and look at that, the line shows exactly where that point is for figure number 4, would be at 12 as well. Okay, so this here is the graph, the thing that you need to graph, and it's a line in this situation. We'll study lines more, but the reason why this is a line is because it's growing by +2 each time. Okay, so this is the graph. What you're looking to get is just getting these points onto the graph. Connect them with a line, you're good to go. Okay, confusing, right? It might be confusing. We're going to do another example afterwards, so you'll have a chance to practice that here too. Okay, so we have our table, we have our situation. This last one here is the graph. Okay, you need to have all this. You need to have these two axes that you have so you can actually label out what you're talking about in terms of X. We'll label out what you're talking in terms of Y. And then you need the graph itself. This is the graph of the relationship between figure number and number of tiles here. Okay, so now we have our graph done. We have 3 of the 4 representations taken care of. Okay, last but not least, we're going to get the equation. Okay, so we're going situation to equation. I'm going to put the double arrow here, even though really we have a situation. I want to get to my equation right now. The equation here, you'd have to think about how we can use an equation's good, or this also is called a rule. A lot of people in classes, they said that this was a rule, and that's all good. So you'll see what a rule is for a second. You got to think, well, if I had to ask you coming up with a rule, how would you get figure number 100? How would you figure out how many tiles are in figure 100? What would you have to do? Think back to the last video. Think about the last thing that I had to do here. Okay, so an equation or a rule is going to be a statement of equality here, in that the number of tiles, okay, remember number of tiles is the y, right? Number of tiles is the y, okay, right? Your output here, this is number of tiles is y. To figure out the number of tiles, for instance, is 4 in figure 0. Start with figure 0. Put that 4 in to your equation here. Put that 4 in equation. So y is going to equal 4 when the number of tiles, x, is equal to 0, okay? X is equal to 0. So if x is equal to 0, we'd still add 4 to it. We'd figure out we'd have to have 4 tiles in figure 0, okay? Is that going to be enough to show you how much is in figure 100? Think about it for a second. What would you have to do to figure out how many tiles were in figure 100? Well, how many times have you changed to get to figure 100? We changed 100 times. How many times is it changing every single time figure number goes up by 1? It's going up by 2. Look, so in the table here, we can kind of see this here. We go from 4 to 6, 6 to 8, 8 to 10. Every single time the figure number increases by 1 here, okay? So what I'm going to put in front of this here is the number 2. Because the idea is, if I'm trying to get figure number 100, for instance, right? If I'm trying to get figure number 100, remember figure number is the x, I would have to multiply that by 2. So we would have 200 new tiles in figure 100. And then we'd also can't forget to add this piece right here, which is the starting amount. And then we'd have 200 tiles right there, okay? So that's plus 4, right? So figure number 100 would have 204 once we simplified everything that's over here, okay? And we can double check that our equation is correct here, okay? So this is our equation. We're good to go here. Double check that it's correct, because when our figure number is 2, we should get 8 here. So figure number is 2. So 2 times 2 is 4 plus 4 is 8. 2 times 2 is 4 plus 4 equals 8. And we're good to go, okay? So here I have my equation here. So the equation is written like this, at least for lines like this, right? The situation where we're changing by adding here, the adding number, the change number, goes in front of x, and then we add the starting number to it to get the answer, okay? So this is a lot of information. I wish we had a lot more time in class so you would be able to go through this with your groups, and unfortunately, we just only have 35-minute classes here, so that's why I'm filming this video. But just to recap this, what will help us recap what I just did down here is by going through this here, using the same color to show where you can see pile 0 represented. We call this the starting number. And then we'll also talk about the growth number in each representation, okay? So you got to do these 2 things on your Desmos assignment here, okay? Using the same color, show where you see pile 0 represented. We call this the starting number. All right, pile 0, okay? So we'll do this in green maybe. Do this in green here. So starting number in the situation, that's pretty easy. This is our starting number right here, okay? And I'll call this SN. All right, there's the 4 right there. Where do we see the starting number in a table, right? In a table. Well, here's the 4. I could just circle that. What I want you to do in tables is circle the 0 as well, because that's the key thing. Trying to find the starting number in a table that's the number for figure 0. Figure 0 is where this pattern begins, right? Where this pattern begins, okay? So circle where we see 0. You look to 0 to figure out what the starting number is. Here's our starting number here. What about the graph? What about the graph? Okay, so again, I want to look to 0 to figure out where the starting number is on the graph right here. And if I'm really just looking for this point, right, for this point right here, 0, 4, where's that? X is 0, so X is 4 here, 3. We got to look further back, 2, 1. X is 0 right here, but what's Y got to be? It's got to be 4, okay? So this right here, my friends, is the starting number, okay? Starting number on the graph. Where did I circle? Where specifically did I circle? What's special about this? I didn't circle over here because it's over 2. I didn't circle over here because that's over 3. I circled over 0. So I circled on this right here. I circled on the y-axis, okay? So the point that the graph touches, remember this line here is your graph, the point that it touches on the y-axis, that's what your starting number is. That's called something called the y-intercept, and we'll study that again, review that again in a couple chapters, okay? So I have my starting number here, my starting number here, my starting number here, and finally, to get my starting number in my equation, where do I look? Okay, I gotta look to the part that's just getting added to it, because if x were 0 here, right, if x were 0 right here, then y would end up being 4, which is what I want, right? So for figure 0, 2 times 0 is 0 plus 4, y would equal 4. So here, the thing that just gets added to 0 has got to be your starting number, because your starting number is when x is 0. Anyways, it hopefully makes sense when we practice them a little bit more. All right, last one here. Let's figure out last one here. Growth number, my friends. Growth number. Let's do this. What color are we doing? Let's do, haven't done blue yet, so let's do blue. All right, so to get the growth number, I'm going to label that GN to get the growth number. And we can do this in every single situation. So let's go ahead and show this. All right, growth number. So 2 people did this awesomely. They did this great on the exit tickets the other day. So I shared both of them. Okay, so growth number. Remember the ways we can show growth in our diagrams? What most people do is this, right? They just draw in where the new tiles are in the pile, in the figure number. So we had 2 new ones here. And then here, right, going from this shape to this shape, we get 2 new ones here. And then from this shape to this shape, look, it cuts over like this. We get 2 new ones up here. So this is a way to show the growth, okay? One way beyond that, one way really clear, a lot of people were praising people when I looked at your comments on the exit tickets earlier, is to use arrows, okay? I love using arrows to show my growth, especially because if the growth isn't by adding, say it's by a different pattern like multiplication, or by a bigger change than just adding the same thing each time, like you did see in pattern A a few classes ago, it's good to draw the arrows, draw them in, okay? So this one was +2, +2, +2, and +2, so on, for as long as the pattern goes, because it's a pattern, right? It continues here, okay? So here is where you show your growth number, here in blue, to this tile pattern right here. Table's pretty easy for showing the growth pattern here. Okay, so we go from one figure to the next figure. The amount of tiles goes up by 2. So what we need to do is we need to go from one figure to another figure. So from a single figure to the next figure. So when we increase the figures by 1, the question is, how much does the tiles increase by? We saw up there it's 2, and we see it in the table. So you can see in the table, we look usually to the right side. As long as these are consecutive, meaning in order, right? 0, 1, 2, 3, 4. The right side is going to tell us where our growth number is. So here is +2 right here. This here is our growth number, okay? And our growth number continues. You might want to do it again to make sure it is indeed +2. So that's how we label the growth number in a table. In a graph, okay, wow, there's a lot of stuff that really we didn't have a lot of time with. If it's been a little while to kind of get what's going on here. We'll review this when we do chapter 2 for sure, but going from one tile to the next tile, right? This is how we show the change. So we go from one figure to the next figure. So the figure is when a figure increases by 1, how much did the number of tiles increase by? Well, on a graph, this graph here is increasing. That's why the line's going this way. So our figure number got bigger by 1, and the number of tiles went up by how much? By 2, okay, by 2. So I put my +2 right here in this. This is something called a slope triangle. You may have heard that about in the past, and we'll review that when we do linear functions. But here, our growth number is right here on our graph. We got growth number is +2 in this situation, okay? Last one here, where do we see our growth number in the equation? The equation's like, a lot of people said going to the equation is what I do first when I have the tile pattern. And it is definitely the simplest out of all of them, which is nice, okay? Because our table has a lot of data in it, right? A lot of numbers. This graph is super messy to do, right? It takes a lot of work to do that graph. Here, if you can get the equation, pretty easy to write, and boom, we have our +2 right there, our 2 number here. So the number touching x, the number right in front of x, they're being multiplied to each other. This is our change number right here, or our growth number. We're calling it growth number, GN, right here, okay? And that's how you mark up all of the growth numbers. Here we have a 2, we have a +2 here, we have a +2 here in our slope triangle, and we have a +2 going from one tile to the next, okay? Let's see how long this video has been, and then we'll jump into the next ones that we have here. It has been, oops, not showing me. Sorry, guys. 20 minutes, okay? So in the next 10 minutes, hopefully I can get through 2 more examples. So if this was a lot of information, too overwhelming, the next one we're going to do together. I'm going to say less, and we're going to do it. And then finally, you'll get one at the end where I'm just going to do, and you can watch at your own pace. And do it first, right? Do it first and then watch to make sure you got the right answer, okay? So what we just did right there, that's called an I do. Now we're going to go to a we do. We're going to do it together. Different pattern tile. Let's knock this out of the park. Let's do this right away. Are you ready? I think you are. All right, pattern T, what's that? So we're showing entire pattern right here. What part of the rule of 4 is this? So this is the situation, okay? So we start with a situation. We got a particular growing tile pattern. There we go. This is a situation. And what we're going to do is we got to get 4 things going. We got to get, well, 3 more, right? We start with 1, the situation. We're going to need to generate the other 3. Let's start over here. I start with table. That's the easiest one to do. X is the figure number, and Y is the number of tiles here, okay? We got the, we did this last time, the last video I made, so let's just check this out here. What's, okay, 1 getting added on over here, another 1 getting added on over here, so we're going by +2, I think. Yep, there and there each time. And that's going to allow us to draw the figure. So this one's going to disappear, and that one's going to disappear. So this would be figure number 1. Four in the vertical, and then 2 over here. Okay. So at an x is 0, y equals 6. Okay, we're getting bigger by 2, so this should be 6 plus 2 is 8, yes. So we have 8 here. Next one, we have the original 8 here, and then we added on 2 more. There we go. So we have 2, we have 10 tiles right here. And let's just count figure 3 just to make sure that we're right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes, 12 for the table here. And we're done. We got our table done. Next one. What am I doing next? Well, I'm going to do graph because these points in the graph, okay, the points in the graph will, or sorry, the points in the table, we'll put on the graph here, okay? So here's what I'm doing in the graph is I'm going to do an L graph. This is the first quadrant. This is where everything positive is here. Remember, were you paying attention on the last video? Because it's been a while potentially since you've had to worry about this. But remember, if I go to the right, go left to right, numbers get bigger. So these are all positive x values. Positive x values. Remember, x is the figure number. Okay? And then if you go up on a graph, you go up. Remember, up, down is your y-axis. This is your x-axis here. This is your y-axis. You go up on the y-axis. That means your y values are getting more positive, getting bigger. Okay? And y is the number of tiles. All right. So the reason why I can get away with this L graph here, I'm only going, so this here is 0, 0. So I'm going to put 0 here, 0 here, because 0 for y, 0 for x is right here. And the reason why I'm doing that is that all my numbers are positive here. So if I go to the right from 0, numbers get bigger, and that's fine because I start with 0, and I got to get 1, 2, and 3. So let's do that. 1, 2, and 3 as we sketch this out. And then I got to get up to 12 to get here. Okay, so what am I doing here? I'm probably going by like 4s basically here. All right, I'll go by 2s again, just so we can see it a little more clearly. 2, 4, 6, 8, 10, and 12. All right, let's do this. Let's get this graphed in. 0, 6. We got a point right there. 1, 8. We got a point right there. So here I'm just transferring, right? Start with your table, and then transfer your points over here. X equals 2, so go to X equals 2, and I'll go to Y equals 10 up here. We got another point right there. X equals 3, Y equals 12. I got another point right there. And you know what? I can connect this with a line, right? This would be a line because, again, our change is by +2 each time. Graph done? Yes, it's done. We're all good to go. Now we're on to the equation. All right, the equation here, okay? You guys remember how to do the equation? Well, we got to do the equal sign here, okay? Y, I would put the Y first. Remember, Y is the tile number, right? Number of tiles. How many tile numbers are there in the first figure, Well, the amount of tiles have got to be at least 4 because that's in the first figure, okay? So I'm going to put my 4 in there. And then remember, how am I going to fill out the rest of the equation here? So we start with 4, and then what do we add to it each time? We get bigger by 2. So what I'm going to do is 2x. And there's that. We got our equation right here. Hooray. We are good to go. Our 4, we had situation, table, equation, and graph. So we've now taken care of number 1, complete the 4 representations of the tile pattern. Number 2, we will do that in green. We'll figure out where the starting number is in each representation, okay? Figure 0, that's easy. That's where our starting number is, this figure right here. Graph, where's our starting number? Well, it's where figure 0 is. Figure 0 is the x value, so I'm going to go to 0 for the x value, and I'm going to go up to 6 because that's where it looks like my graph is hitting right here. There is my starting number. Where is it in the equation? Okay, where is it in the equation? Well, our starting number is 6. Oops, I wrote this incorrectly up here. This equation should not be 4 right here. It should be 6. Okay, because we had 6 tiles at figure 0 here, okay? So my starting number here is 6, okay? 6 right here. So starting number always appears there for a linear equation like this, for equation for a line, right? And that's when change is consistent. We'll have our starting number there. And finally, we have here, 0, 6. We have our starting number. Good to go? Yeah, we're good to go. Stop, rewatch the video if you're not good to go. But I'm just going to jump on to the last one just to kind of wrap things up for you guys in case you're just rewatching this as a refresher. And final one is the growth number. Okay, so how we're going to show growth? Well, growth, it looked like we grew right here, and it looked like we grew right here from this first one right here. Okay, same thing too, right? We grew with another tile right here and another tile to the left right here. So we're growing by how much each time? Here and here. We're going by +2, okay? So here is labeling the growth in this tile pattern, labeling the growth in this tile pattern, and labeling the growth and going from that tile pattern to that tile pattern, okay? So we have the growth labeled in the tile pattern. Now let's go to graph. Let's do it in graph here, okay? So going from one tile to the next tile, I'm going to draw part of a growth triangle right here, a slope triangle. So as our x gets bigger by +1, how much bigger does the number of tiles get? Figure number gets bigger by 1, tiles get bigger by 2. Here is our growth. We got bigger by 2. We went from 8 to 10 on the y-axis. So our growth number here is 2, +2. Growth number in the equation, you guessed it, right there, right? The one touching the x is the growth number. X gets bigger by 1, then we got to add 2 to it. So if you're getting bigger by 1, 1 times 2 is 2. So you've gotten bigger. Your number of tiles have gotten bigger by 2. Finally, table. Where do we see +2 in the table? That's right. We look to the right side here. Going from 6 to 8, that's where our +2 is. So that's our growth number. I'd recommend also to doing this, just making sure that your table is showing, again, it's called consecutive numbers going in order, getting bigger from 0 to 1. And there you have it. We've knocked out number 3 right there. We got it good to go. Okay, so I know that I went 20 minutes doing the thing by myself, 8 minutes or so. Did it with you guys right now. We got one more. If you want one more practice, you can do this one on your own. I'm going to be sitting here. I'm going to be doing it just by myself. Fast forward, check the answer when you're done. And that's about it. Okay, so I did an I do by explaining in detail how to do the rule of 4 and to mark up the change number and starting number. Then I did a we do by kind of like you've seen it already. I'm going to do it more quickly. And now I'm going to do a you do. You guys try this on your own. Try to answer this 1, 2, and 3. Email me if you have questions. Watch the answers when you're done. Thank you so much for joining in. Talk to you soon. Thanks, guys. Bye.